All right, so recording started. Then, oops. So before we get to what's on for today, let's get a quick introduction by each of the authors. So yeah, I'll start if I may. My name is Björn Wunzmann. I'm an independent IT consultant. Yeah, from a high-level business perspective, I help companies turn their business into a digital business. On a more practical level, that means, for example, making data available and accessible via APIs, or automating business processes with the help of software applications like the ones we talked about in our book. I also coach software teams when it comes to the adoption of technologies such as Angular or Spring Boot. I'm also an avid blogger on my own business website, which is where I usually write about software, business, and technology in general. So yeah, that's it for my part. Let's hear about Tom. Tom, if you'd like to go next.
Sure, I'm Tom. I'm also a software developer / consultant, have been long time consulting in Germany. Have recently moved with my family to Sydney to work for Atlassian. This is where I'm currently at, so it's dark outside where I am, while others are having lunch, I heard right now. Anyway, I love to write about what I'm learning. I have a blog on Reflectoring.io on which I write about Spring Boot and recently also AWS. And yeah, my passion is to make things as simple as possible because my brain just can't understand complexity. And I hope that we made the book as understandable as possible. Over to you, Philip.
Yeah, hi, I'm Philip, a freelance software developer from Berlin, Germany. I have been working with Spring Boot for now almost 5 years in various industries and projects. Besides this freelance work, I'm also running a blog and a YouTube channel, which has the main theme of testing Java and especially Spring Boot applications to make the whole testing part a little bit more joyful with nice recipes on how to test different parts. And I'm now super excited to release Stratospheric together with you.
All right, thank you, Philip. Thank you, Tom. So yeah, let's just... Yeah, so what's on for today? We've got a packed schedule. First, Philip will give us a quick walkthrough of the sample to-do app we developed alongside the book to serve as an example for the services and techniques we used throughout the book. Then afterwards, Tom will tell us about a CI/CD pipeline on GitHub Actions and how that works together with AWS services and the CDK. Yeah, then the big moment we've all been waiting for, we'll hit the release button together. And yeah, finally, as mentioned already, we'll have plenty of time for you to ask us anything during our Q&A session. So, all right, I think at this point, Philip, we'll get a quick walkthrough of the sample to-do app we developed for Stratospheric. So, Philip, your stage, you just need to see control of the presentation so you can share right now.
Yes, let me share my screen. Yes, let me share my screen. So you should be able to see Chrome.
Yeah.
Works, okay. So I will start with a short sample, with a short walkthrough through our sample to-do application. So as part of the book, we have the big goal to be as hands-on as possible. So together, throughout the book, step by step, we built a application together, which I will now showcase. And first, we have a quick look at our basic technical overview. So this is really on a high level what we are going to build. Let me get the laser pointer here. So on the left side, you see a front-end application running inside the browser We went for thime leaf front end, and the whole domain of our application is about to manage to-dos, create to-dos, share them with other collaborators inside the application. The whole communication with the backend happens both via a REST API and also WebSocket. So we have some push notifications, which we'll also see with a short demo later on. Inside AWS, we are running a Spring Boot backend using Spring Data JPA, Spring Web MVC, and also have a high emphasis on Spring Cloud AWS and also Java. When it comes to persistence, we want to show you the best of both worlds. So we have both a SQL database connected, a Postgres flavored Amazon RDS, and also Amazon DynamoDB to really show how to connect to both SQL and NoSQL databases. Furthermore, we also connect to various messaging systems. So as one operation of our application is to share to-dos with a collaborator. This is an asynchronous process where we send out an email to the other user, and we wanted to showcase how you could decouple such business operations, which could in theory also be accomplished by another microservice inside your architecture. So we publish messages to Amazon SQS, which is a basic queuing system, and also then resubscribe to the same queue, which in theory could be done by another application, but then to really decouple. And also, as we are running with multiple instances, so Tom will also later on show you really the runtime overview and more technical AWS infrastructure, we are scaling out. So to avoid the likelihood of a downtime because one instance is down, we are having multiple Spring Boot instances running. And to make sure all WebSocket messages come to the front-end users, depending on which application in the background they are connected to, we also subscribe or connect to a Amazon MQ to have a WebSocket broker relay. So that's really on a high level. There are way more AWS services we work with and connect, but that's the basic use case of the application. And I will now go on to a live demo to showcase really what I just showed you on a high level architectural overview, how it looks in production. So let's switch the tabs and let's reload here. So as you see, the whole application is running on a custom domain. Everything is protected with HTTPS. And we have here a nice looking simple landing page where all users come to if they are not logged in yet. So they at least still see some information. If they try to navigate, for example, here to the dashboard, we will also be redirected to, this is now Amazon Cognito. So for the whole user management, authentication and authorization, we didn't want to implement this on our own. So we took something off the shelf, and in the AWS context, this is Amazon Cognito, which is a managed service to really get the user management ready for an application by just bootstrapping the service. And as we are currently not logged in, let's create a new user as we want to see something behind the login protection. So as mentioned, every user is managed inside this Amazon Cognito service, but we still have the front end to create such users. So let's call the user, let's say, live demo. For the email address, I have here a disposal email service. So let's quickly go here. Also to keep us protected from bots, we have here an invitation code, so not every user can register here. And if I now click on submit, I will see the email is already registered. That's not good. Let me quickly, doesn't matter. Let's take another service. I already took this. Let's use this disposal service. So we already see here, we have a check that the same email can't be submitted twice. So now I have successfully registered. As you've seen, I have not created any or not entered any user. We now have here, unfortunately, it's German here, sorry, but as you see here, here's a basic email coming from Cognito, really basic. We just need the basics here, which has the temporary password, which I can now take and log in. Let's pick the user again. So here This is now a sign in window from AWS Cognito. You could also customize this with custom logos or fonts, but for our use case, it's really just basics. Now let's pick an actual password for our user, because this was just temporary. And once we submit it here, we can see we are now logged into Stratospheric. We are redirected to the dashboard. So in the background, OIDC, OpenID Connect is used. So the whole authentication and authorization happens on Amazon Cognito. Once the user is authenticated, it will be redirected to our application and is now logged in. We see here a nice greeting message. We know who is currently logged in. And what we can now do, we can create our first to-do, as this whole application is all about managing to-dos. Let's enter here a simple to-do. We can add a priority here and a due date. Let's put it somewhere in the future. Let's hit create. So and here in the background, this to-do would be now stored in RDS. So in the Postgres database, we now store this entity and now have here a really simple dashboard of our currently to-dos. There's only just one. We implement the whole CRUD API, so we can read this to-do again and take a look what we just have created. We can click on edit to update it. So let's quickly do this. Let's put in here. We might in the future also release a next version if we find a typo or so. Let's update it here. And now this is also updated. Let's add quickly another to-do. Let's say here, showcase application. Do it quickly here, test. So while this application is really basic, in the background, we emphasize on the building blocks. So with the building blocks that you learn throughout the book, you will be able to apply this to your domain. And we just use the to-do application domain to have a understandable but not too easy application to showcase all the technology we are using. So now we have here another to-do. What we can now do, we can also delete this to-do. That's fine. Let's quickly do this. And the last feature I now want to show you is sharing a to-do. So to showcase the application, I don't want to do this alone. I want to share this to-do with someone else. And we have here a list of registered users. And to now see this in action, we actually need to be logged in with another user. So on the right side, I will quickly go into Stratospheric with my user. So let's log in here. Let's go to my dashboard. Okay. We see here, this is now my user. I also have two to-dos. And in this example, let's say, okay, I want to share this release task with the live demo user. So I now see here all other users of our application. I can now click here on invite. So once this finishes, we will see here, we now have successfully shared our to-do, but as the other person might not want to collaborate, the other person has to first accept it. And what we did in the background, we sent out an email with Amazon SES, so an email service, which makes it really simple for us to send out emails to users. And as you now see here, inside our disposal email address, we got a new message. Someone shared a to-do with us. Here are the specs of the to-do. If you're interested in this, you can click on here and accept the invitation. So let's quickly do it. And while we do it, keep your eyes on the right side, because we now should see a pop-up, a notification based on WebSockets. As you see it here on the right, collaboration confirmed. So without reloading the browser, this is now the WebSocket architecture live. You now saw in the meantime, the other user now accepted the invite, and I'm now informed I can now collaborate on this. And on the left side, we will see here, this live demo user now has a new to-do. It's shared with him. He can take a look at it for sure. And as it is shared, also can make changes. So let's edit here. Do it to together. Let's update it. Must be future date, that's for sure. Let's also update here the date. And if we then reload here on the right side, we also now see here there are no more pending collaborations. So as the other user accepted it, we will see here 2 collaborators. And if we go into the description, as you just saw, I changed here slightly the description and now collaborated on this to-do. So that's really the basic use cases of our application. And all of this is automatically deployed to AWS with an entire CI/CD pipeline using GitHub Actions. And Tom is now about to showcase this CI/CD pipeline and how we use the AWS CDK, the Cloud Development Kit, to express our infrastructure needs with Java and how to automate this whole pipeline using GitHub Actions.
Yep, thanks for the tour, Philip. Let me share my screen. You should see a very nice looking, colorful diagram now. Okay. Yeah, so Philip showed the application, the to-do application, which we're going through in the book. And this application obviously is hosted on AWS, and I'm going to explain a bit how it's working, how we're deploying the application to AWS, and which AWS resources we're using. If you've never heard of AWS before, that's fine. I'll explain each of the AWS resources we're using a bit. I'm not going into the full detail, but that will surely be explained in the book. And if you have any questions, feel free to post them in the chat or Slido. All right, so this is the infrastructure that we deploy on AWS. First of all, we have a Docker repository. AWS has a service called ECR, Elastic Container Registry, which serves as a Docker repository. For an CI/CD pipeline or continuous deployment pipeline, as we build it for the book, we need to create a Docker container, or a Docker image rather, and push that image to some kind of Docker repository so it can be pulled from there. And this is what this Docker repository is for. And then we have multiple environments. I call them staging and production, and there can be more than these two. It's just these two that I put on this diagram. And this is for each of the environments. First of all, we're going to create a VPC, Virtual Private Cloud, which is Amazon's, AWS's network isolation method. So you have a VPC for each of your applications, or you have a VPC for your whole organization as you want it to be. In our case, we have decided to have one virtual private cloud per environment of our application. So one for staging, one for production, one potentially for other testing environments. This is basically an isolated network in the cloud, which can be public or isolated, as we'll see next. Into this virtual private cloud, we're going to deploy a public subnet and an isolated subnet. A subnet is basically a range of IP addresses that we can use on AWS, and a public subnet is accessible from the internet, and an isolated subnet is not. Isolated subnet is only accessible from other subnets or other resources as we specify in AWS. Into this public subnet, we're going to deploy an ECS cluster. Sorry. ECS is Amazon's Elastic Container Service. And an ECS cluster is responsible for managing a fleet of Docker containers, if you wish. And And into this ECS cluster, we deploy an ECS service. And an ECS service means, okay, we have this one application which contains of this, and this Docker image. Please spin up a Docker image for each of a Docker container for each of these 3 images and put them together in network in some configuration that we want. And an ECS task is exactly one Docker image, which ECS then spins up as a Docker container. And to make this, make these Docker containers that are running in the ECS cluster available from the outside, from the internet, we're going to deploy an application load balancer that takes the internet traffic, routes it to the Docker container that is running our Spring Boot app. That's running our to-do app. And as you can see, we have 3 different colors here, which mean we have 3 different stacks. A stack is a unit in AWS in the CloudFormation service. That's the name of the service. A stack is the unit in which we say, okay, we have a bunch of AWS resources that we want to deploy, and we can put them all into one stack, and then we can tell CloudFormation, the AWS CloudFormation service, please deploy the stack. In this case, in the Docker stack, it's just this one resource. It's just the Docker repository that we use to publish our Docker images to. The blue ones here, the blue resources, are part of the network stack. But we called it network stack, so that's our personal preference. It doesn't mean that everybody should do it like that. This is just how we decided to do it. So we decided to have one network stack per environment. And then into this network stack, we can deploy a service stack, which deploys our Spring Boot application. And the ECS service and ECS task is the resource on which the application is running. We decided we could put everything into one stack. Then we would only have to run one command to tell AWS, hey, please deploy all these resources in this one stack. But we decided to split it up because we might want to have multiple different applications running in the same staging environment, in the same production environment. So we could deploy one network stack with all the blue stuff, with all the blue resources. And we could, for example, decide to deploy 2 different ECS services for 2 different applications and deploy both of them into the same staging ECS cluster. Okay, so that's already a lot to digest, especially if you don't know AWS as well. But this is discussed in further detail in the book, of course. We need some way to get the resources deployed in AWS, and this is what we did with CDK. CDK is AWS's cloud development kit. And if you look here on the right, you see this is the GitHub repository from our book, from our app. You see we have quite a few CDK Java classes here. So we decided to use CDK for Java because the book is about Spring Boot, and Java is very close to Spring Boot. And we have multiple apps here, CDK apps. For example, we have our network app, which is about all the blue resources here. I'm just going to quickly show how a CDK app is structured. So we are instantiating an app here, which is a CDK class. We're taking some input variables. And then we're creating a stack. This is the unit that we put all the resources in. And then we're creating a network construct. That's the word that CDK uses. And the network construct, that we created that in ourselves. The network construct is part of our construct library, which is a separate GitHub repository. and we can have a quick look into it. The network construct is a bit more complex. Well, not really complex. It's just long. It's not complex code. It's just long code. And here you can see on the left side we have a VPC. Here we create the VPC. I could go in there. And the VPC creates some public subnets and isolated subnets, which we see on the diagram here and here. And then it creates the VPC and so on. It creates the ECS cluster and the load balancer. So everything that we see in the blue here. We have move these zoom controls away. And that's it. So basically, you create a CDK app. The CDK app creates a stack, and we add constructs to this stack. We either use constructs that the CDK provides for us, or we create our own constructs out of the constructs that CDK creates for us. And that's how an app works. And we have a lot of different apps because we wanted to make it very distinct. It's also easier to write about it this way. We have an app that creates the network, as we've seen. We have an app to deploy the green resources, our actual Spring Boot app into the network, and we have apps for all the other Spring AWS services that we're using. For example, for the messaging that Philip showed, for the push notification, where we have an app, a stack that deploys an ActiveMQ cluster. And the SQS queue that we're using. We have a Cognito stack, which uses the Amazon Cognito service to do the user login and registration and stuff like that. So all of these are explained in the book. Now we want to deploy, we have these CDK apps. How do we get the resources in these CDK apps actually to deploy to AWS? And for this, we created a GitHub Action, continuous deployment pipeline with GitHub Actions, which contains of these two different workflows. We have one workflow that builds and publishes builds the Spring Boot application, and then publishes a Docker image to our Docker repository, to this Docker repository here. And it then triggers, puts an item in a queue somewhere, so it gets deployed at some point. This is to make it possible. So if two, because this workflow is triggered with each push to the repository, and if two pushes come very close to each other, it can be that one build is still running and the other build will fail deployment because there's already a deployment running. So we decided to queue it. I'm not going to explain this in more detail because it's quite complex. It goes into an SQS queue, and then we have a Lambda that reads the items from it and then triggers the deployment workflow. And that's the interesting part again. The deployment workflow triggers deployment. Quickly going to show how this looks. For example, let's look at the deploy workflow. This is the deploy workflow for our staging environment. And the interesting part is here, we run an NPM script because we wrapped the CDK application, the CDK application in NPM, and we just run this NPM script, service deploy. Service deploy is exactly the service means these green resources, so it will deploy or update the green resources, which include our Spring Boot application. So every time someone pushes a change to the code of our application, we update these green resources, and we pass in some parameters. Among these parameters is the tag of the Docker image that we want to deploy. And that's it. And we have to wait a couple minutes, something between 10 and 15 minutes usually it takes to rotate through through the whole deployment, and then the app is updated. And that's basically it. This is just a wrapper around CDK. It's not very, I can quickly look into, show how this is looking in the CDK chapter. We have our package JSON. And we can see this is the command that is being executed. It's just a CDK deploy command. We pass in the app, and the app is our service app. And this tells CDK, please deploy everything or update everything that is declared, all the resources that are declared in this app. And that's it. This way, we've built all the CDK apps in the book. Everything that we talk about in the book is all the AWS resources are deployed in this way, as you can see by the number of steps here. That's all I wanted to show about the AWS resources and how we deploy them and how we talk about them in the book.
May I quickly add something?
Sure.
Yeah, maybe just to those that have never seen the CDK before. So the real benefit is here we have infrastructure as code. So we don't go through the AWS console to create our resources, which is error prone, and the user interface changes. So if we would publish a lot of screenshots and you read the book in 6 months and AWS decides to update the user interface, for example, it would look entirely different. And with the AWS CDK, it's for us even better than plain CloudFormation, because with CloudFormation, we would have this endless JSON or YAML files. And now we can stay inside our developer environment, inside Java, use Maven, the tools we already know from developing our applications, and express our needs with Java objects. So there's an object database, and this will then in the background create all the AWS infrastructure resources for us without having us ever to log into the AWS console, select the size of the machines, because benefit also here, if something goes wrong, we have to, on a Friday evening, redeploy, I don't know, the database. Doing this in a rush in the console is, I guess, not the best effort. And here really everything is automated, expressed with code, and changes can be also reviewed and then automatically applied to our infrastructure.
Yeah, thanks for adding that. If you have any questions, feel free to add them into Slido. We'll talk about them in a minute. For now, let's click the button. Are we ready to click the release button? There have been some questions about how our workflow was to publish the book, and maybe we'll talk about them in the questions later if they're interesting for enough people. We published the book on Leanpub, which is a self-publishing platform. It's pretty nice. So we wrote the book in Markdown, which I can maybe quickly show here. We have a GitHub repository, and we have a lot of Markdown files. And from these Markdown files, we generate the book. And the book is actually generated by Leanpub for us. So it's getting it from the GitHub repository and publishing it from there. So the new price of the book, I think, is, we decided on $39. Is that right? Tell
Yes.
me if I'm doing anything wrong. So, okay, price is updated. Then we have to update the progress bar. This is the progress bar that you see on Leanpub down here. It's not 80% done, it's 100% done, hopefully. No, it is. It is. I wrote part of it, I know it. Does that say 100 now? Okay, this is still a lie because it's not published yet, but we're going to do that now. And like I said, I hit on publish. And this is taking the book from the GitHub repository and publishing it. You know what? I forgot to add the release notes. I knew I would forget that.
They will come via mailing list. No problem.
Anyway, here, I forgot to click this button and add some, so the Leanpub users would know what changed. But anyway, they will know with the next version. Someone will tell us they found an error anyways, and then we'll have to update it again. All right, so while this is generating the new version, I guess we don't have to wait for that. We can move on to the questions. I'll pass over to Björn.
I would take it, or?
Oh, sorry, yeah, Philip, you need to find the right button.
So
you need to find the right button.
So I guess we have still your attention. So while the book is now being published, we still have some minutes left for the Ask Us Anything session. So at the beginning of this release party, we shared this link to Slido. I would still give you 1 or 2 minutes to now, as you have seen, a little bit more information about the book and the process, to enter your questions and also vote them with the thumbs up feature here of Slido. And then we would take the remaining time to go through them, answer them, and also no worries if you have really burning questions which we couldn't answer now. We will answer them all by the mailing list. So at the end, once the release party is done, we will publish all the answers to all your questions. So if you don't get that many thumbs up, don't worry. There are already a lot of questions. So if you see, or if you want to enter a new one, maybe take a quick look if you're not inserting a duplicate. And then we will go through them step by step. Okay, so I would say 1 or 2 minutes, and then we can go through them. You can upvote as many as you want. And we go top to bottom, what interests you the most. Okay, I would say we can start. Let's have a look at the first question. Is there a Discord or mailing list or a hashtag for working through the book in groups?
Yeah, I guess we haven't really thought about that, have we? But it's a very good idea. I was thinking maybe opening up a Slack channel or something.
Yeah, might be a good idea. So, or Discord, maybe we have to check which of those tools suits our needs best. But I think it's a really good idea. Yeah.
As we also have some further plans after the book, maybe this can also have a synergy there. So maybe as a small sneak peek, we also plan, if there is a lot of interest, to create a online course for it, to have a little bit more hands-on and a little bit more guidance from us. And maybe as part of this, there will be also a student group or something to further collaborate and ask questions. So that's a great one. I guess it will come. Okay, next question. Why was the decision made to use CDK when there are mature alternatives like Terraform, Sceptre, etc.?
Yeah, I think ultimately the decision was made because all of us knew or know Java very well, and we wanted to express the deployment workflow in a language we were familiar with. So that was basically the motivation behind using CDK, in contrast to alternatives such as Terraform.
Yeah, the idea was because we're talking about Spring Boot. Spring Boot is a JVM-based framework. So we wanted to try out if CDK, because it can also be expressed in Java, and these two together, like the difference in the ecosystem is not as big. Like then you can really, as a developer who's building the Spring Boot app, you can also do the CDK, build the CDK apps without even switching the language. That was the main motivation, I guess. We know there are other tools like Terraform. We originally wanted to use CloudFormation, which is the underlying service underneath CDK, which is defining all the resources. But that would have required YAML or JSON files, which are not very readable and maintainable. And since CDK was starting to get, well, I'm not sure if I would say mature yet, but it was starting to gain traction last year. We converted to the new way, and it feels good to do it that way. So the decision, in my mind, was not a bad one.
I can also add, I had some nightmares about big YAML CloudFormation files. So the CDK was also something to explore and learn. And that's also why we did it. And I guess there were many other resources which have this look on from zero to production. There are on the internet a lot of blog posts that touch parts of CDK, how to deploy a backend database or so, but really have the whole overview about everything. And it worked out great. There were some times where we had to fight through some GitHub issues for sure. But we could manage to do it, and it's working really great and stable. And as the underlying technology is still CloudFormation, we can also take a look at the outcome of CloudFormation and also tweak it there if there's something not working.
If you're comfortable with TypeScript, you can also use CDK with TypeScript. That's a bit more stable than the Java version, it feels to me, because the Java version also builds on top of JavaScript, and TypeScript is just closer to that. So if you're comfortable with TypeScript, you can just as well use TypeScript to define your stacks.
And I think Python too.
Yes.
Yeah.
But Python probably, I haven't looked at it, but Python probably also builds on top of the JavaScript engine. And it's just one step further away from where the action is, and where potential errors. So we had a couple of errors that we ran into that were because of the JavaScript engine that did not quite work with the Java engine, and they had to fix a couple things. But yeah, mainly it works. There are some tweaks that you have to do when you're doing a little more exotic stuff.
Okay, let's go to the next question. Will this book, or if there is another question on top of this, feel free to enter it in the Zoom chat if we didn't answer it to your expectation. The next one would be, will this book be a great addition for people with Spring Boot, but little to no AWS knowledge?
Yes, absolutely, because that's how we, or rather we approached it from exactly that perspective. So if you have some Spring Boot, some Spring knowledge, but little to no AWS knowledge at all, this will be, we think, the perfect guide for working with these two technology stacks. So yes, absolutely.
Okay, I guess nothing needs to be added here. Let's move on. Does the book target all AWS services which integrate with Spring Boot?
No, I don't think you can write a book about that. But it is integrating the AWS services which are most commonly used in generic web application development. So we have RDS, so a SQL Postgres database, DynamoDB as a NoSQL database, messaging with the SQS and ActiveMQ. We're using Cognito to do user registration and login. We're using SES to send emails, which is another very common task in applications. I probably forgot some things, but these are the main use case. And the others, like once you understood the workflow of, okay, these are the resources that I need in AWS and how you can deploy them with CDK, the rest is probably pretty similar.
And I guess as AWS provides a Java SDK for all of their services, so I guess literally every AWS service integrates with Spring or Java. So this would be quite a lot to talk about. And we really focused also where Spring Cloud AWS, this helpful layer on top of the Java SDK from AWS, really adds benefit and makes it really convenient to connect to those servers. And I guess there we really tackled 80% of that, what you will use from day to day. Okay, next question. Can ECS, so ECS was Elastic Container Service, be easily replaced with EKS, Elastic Kubernetes Service, if required? Basically, can the material in this book be applicable to the Kubernetes-based deployment environment?
I would say very much of the book is applicable to EKS, so Kubernetes as well. Personally, I don't have experience with EKS, but pretty much everything except the service stack that was the green resources that I showed in the diagram earlier. Pretty much everything else is independent of ECS and can be replaced with EKS. So yes, most of the book is applicable. The pieces that are missing, you would have to replace the ECS resources that we're using with EKS resources. That's about everything you need to do, I'd guess.
I guess as also with Kubernetes, the deployment unit is a Docker image. So from this level, the application can be also used in EKS if the infrastructure is in place. Okay, next question. Do you have any plans for further books content around Spring/AWS?
Yes, we do. The basic idea is to provide an online course which takes some segments of the book and provides them in the way of an online course. You can easily follow along.
We also had several requests already. When will the same structure come for other cloud providers, so Azure or Google? So I guess at least for me, the knowledge with these cloud providers is a little bit more limited. There might be no book about, at least from us, for other cloud providers, but in general, there will be more from us.
Yeah, in any case, there will be content about AWS on my blog, and I guess on Philip's blog as well, and Björn's as well. So if you subscribe to our blogs, you'll probably get some hands-on AWS knowledge as well.
Okay, next question. Let's take a look at the time. I would say maybe 10 more minutes and then wrap it up. We start a little bit late, so 10 past.
Good idea. Yeah.
Good idea. Okay. What's your experience as a co-author and impressions for this adventure?
It was good. It worked quite well. I usually like, well, I'm a bit of a stereotypical software engineer, so I like working in with the shutters in front of the windows and nobody disturb me and stuff. So I like to work by myself. Work quite well together with Philip and Björn. We approached this project like a software development project. So we had our sprints, and every 2 weeks we met and discussed what we did and the next steps. And we did that for a whole year. I don't think we even missed one of the sprints, did we?
No.
We met every 2 weeks.
Yes.
Yeah. So yeah, we basically, as Tom just said, approached this like a software development project, and quickly and organically evolved into an agile process. So we met every 2 weeks on Zoom and exchanged what we had done until this point, and also in terms of writing. When one of us wrote a chapter and was finished with, or said it was finished with that chapter, that person created a pull request for the others to review. So basically, like your usual software development process works these days.
And for me also, it was a lot of new knowledge, because having written a lot of blog posts, but never really someone who look over it. And with this pull request approach, 4 more eyes, which greatly improved also, I guess, our all writing styles, which made the text a little bit more clear and really challenged also some sentences. Everything worked out great from a collaboration perspective. We also split marketing tasks. So as some of you might be on our mailing list since day one, we also roughly wrote a blog post every 2 or 3 weeks where we reported our current status, gave more links to further reads. So all of this was split among us, and really great adventure, I would say, and it worked out really well. Also, having published this in a self-publishing manner, there was no pressure from outside, but as we were all eager to learn more and really dive into these topics, it was our own motivation to proceed and not report no status in the daily. So that's also was great adventure here. The next question: how much does the AWS infrastructure we are building as part of the book cost per month?
I think it's about 100 euros per month right now. So about 100 to 110, I think, depending on the number of deployments. Because sometimes, for example, if you recreate the ActiveMQ instance, which serves as the relay for the WebSocket feature, this also incurs costs. So it depends on the number of deployments and also, of course, on the usage of the application. But in general, right now, it's about 100 euros.
Yeah, but I guess also some parts of the architecture could be shut off if you really don't need this queuing system in the background or only one database. You could tweak this to your needs. From a cost perspective, I guess maybe it's too much for a pet project if you really do this on a hobby side, but for a small scale startup, or you have a nice SaaS idea, I guess then it's really a really good choice, and a lot of parts can also be adjusted, and smaller instance sizes, there's a lot to tweak. Okay, how did you write the book?
I think we just answered that, didn't we?
Yeah, I think so.
So maybe in short, it was written all in Markdown. Leanpub, the provider we used, has a Markdown flavor, which adds a little bit more syntax to it. We used a GitHub repository, which remains private, to collaborate. We used feature branches to write, then created a pull request, and automatically, as we saw on Tom's screens, Leanpub creates this nice looking PDF out of the Markdown files for us. So this was the writing process. So no word adjustments or resizing any tables. It was a really good experience, I guess, from our side. Can an AWS setup be configured to shut everything down if the bill reaches X dollars?
Unfortunately, not that I know of. I tried to research this, look into this as well, but I'm not aware of any such feature. You can create alerts within the billing console, but this will just notify you once a certain threshold has been reached. But you can't really automatically shut down everything if the costs reach a certain level.
But I guess there might be, I mean, everything in AWS is can be tightly integrated. We have this cost alarms, which for us just wrote an email at the end of the month, you're reaching your threshold. But I could guess maybe there can be an event configured, which then triggers a Lambda function, and this Lambda function then executes CDK commands. So I guess with some tweaks, you might automatically shut down your environment if costs are getting too high. But we didn't do this, so yeah. Okay, the rest of the questions weren't upvoted, so they are not in order.
I think we can close here because for some closing words, we will answer all of the questions, even the ones that we didn't talk about now, in the newsletter. So we'll definitely send out some information to all of you if you're in the newsletter, and all of those that couldn't be here today. So we'll answer all the questions there. And I think Björn, you have some final closing thoughts, right?
Exactly. So let me just share my screen again. So yeah. So before wrapping up, we have some another short announcement. I think Dennis isn't here anymore. So Dennis Traub, he runs the AWS podcast in German. So this is something for the benefit of our German-speaking audience. I think he just published a new podcast episode featuring an interview with the three of us authors. And yeah, so if you speak German, if you understand German, you can check out this this podcast. And I just post the link on. Let me just see. I will post the link later on. So that's something that might be interesting to you as well. So anyway, right now, I think, yeah, that's it for today. Thank you. Thanks everyone for attending today's event. And yeah, as Tom mentioned, there will be a follow-up newsletter issue where we'll try and answer any remaining questions. And in that newsletter issue, we'll also include a link to the recording of this event. So yeah, make sure to subscribe to our newsletter if you haven't done so already. Yeah, we hope that the book has provided or will provide at least some value to each of you. And we also hope you liked today's release party. At least I can say the three of us authors had a blast. Anyway, yeah, we'd like to continue hearing from you. So please do reach out. And yeah, thanks again. Goodbye from my side. Goodbye, everyone, and have a great day.
Bye-bye.
Thank you, everyone. Bye-bye.